So number 3 wants us to try guess and check again. So if you look at the more complicated part of the function here, right, if I wanted to take this using substitution, or using the chain rule, well, if I took x to the 5th minus 4x plus 7, and I took the derivative of this, I can see that it's 5x to the 4th minus 4. So this could be my f of g of x, and this is the derivative of the inside. So that means I could rewrite this, and I could say, well, this is going to be x to the 5th minus 4x plus 7 raised to the 10 divided by 10. But then when I look at this, if I raise this up a power using the power rule, I don't have any constants out front. So if I were to check this, let's see if this works, because I'm not sure if this is quite right. Okay, so now if we check it, let's take the derivative of what we just guessed. So 10 times x to the 5th minus 4x plus 7 to the 9th, right, over this 10. So there's my 10s canceling. And then times the derivative of the inside, and I do in fact get back with what I started. Now, for me personally, I am not a fan of guess and check. I think it's just dangerous and gets into trouble. I like a more systematic approach. So what we're going to do in part B is we're going to learn how to take a very systematic approach to solve these integrals by substitution. So the first thing that we do is we want to write the function g of x. So what I like to do is when we're doing the chain rule, we kind of think of the outside function. So when you're undoing the chain rule, I just see a whole bunch of stuff raised to the 9. So I would say that let's let our u be x to the 5th minus 4x plus 7. So then it says, well, to find g prime of x, then write du equals g prime of x. So if we take the derivative of this function, we get 5x to the 4th minus 4 dx. Now, if we go back to our original integral, we can substitute our u and our du into the integral. So our u was all this stuff right here in our parentheses. So we get u to the 9th, and then 5x to the 4th minus 4 dx was our du. So all I've done is I've simplified the function into something that I can very quickly anti-differentiate. You'll know that you're probably not on the right path with your substitution if you make the substitution and you almost can't do the integral in your head. So the antiderivative of this, well, they want us to integrate down here. The antiderivative of this is u to the 10 over 10 plus c, and I want my final answer to be in terms of x, so I just substitute back in what u stood for. So it was x to the 5th minus 4x plus 7 to the 10th over 10 plus c. And that is what I got when I did my guess and check, but it was a little bit stressful, and now I don't have to take the derivative at the end to check my answer.